Hi everybody, in this video we're going to go over using your linear combinations method, otherwise known as your eliminations method, to solve for systems of equations. Okay, here I added some hints and helpful reminders. Remember that if you end up with an answer that doesn't make sense, for example, some number that doesn't equal the other number, like 0 equals 1, then there are no solutions. And if you end up with an answer that equals itself, for example, x equals x, or some number equals the same number, like 2 equals 2, then there are infinite solutions. Also remember that you don't always have to multiply both equations to get an additive inverse, meaning if I am looking at my systems of equations here, and I know that I can easily create one of the variables to be the same number as the other, I don't have to multiply both of them to get the same number. Okay, so let's get started. I'm just going to do number 1, and I'm going to do it in 2 different ways. Starting off, I see that my 3x minus 14y equals negative 28 is above my x minus 7y equals negative 14. Now, one thing I can do is plan to cancel out my x's, meaning that I want the number in front of my second x at the bottom to be the additive inverse of positive 3. So in order to do that, all I have to do is multiply my second equation by a negative 3. Okay, this will give me, and now let me rewrite the first equation, 3x minus 14y equals a negative 28. When I multiplied for my additive inverse, I now have a negative 3x. My negative 7 will cancel with the negative 3, becoming a plus 21y equals, and I have negative 14 times a negative 3, again canceling out those negatives, leaving me with a positive 42. Okay, remember, linear combinations is meant to help you do less work when there are things that can already cancel straight down. Okay, so linear combinations, now that we have these additive inverses, I just stack and add. So 3x plus a negative 3x cancels. That's why I would also call this that elimination method. A negative 14y plus 21y gives me a positive 7y. Negative 28 plus 42 leaves me with a positive 14. Now I'll simply go ahead and divide out my 7s and find out that y equals 2. Okay, so that's half of my solution. Now that I've solved for y, all I have to do is substitute and solve for x. I have x, and I'm using the second equation just because it seems a little easier. So I'm going to do 7y equals a negative 14, and I know that y is 2, so I can replace that. I can substitute it, and I get x minus 14 equals negative 14. I'm going to go ahead and add 14 on both sides. These cancel, and find out that x equals 0. Okay, so my overall solution is 0, 2. Okay, so if you need to see this again and how this has worked, make sure you go back and rewind. In the next few seconds, I'm going to erase this and solve by canceling out my y's instead. Alright, so maybe you didn't see how to cancel out your x's, but I'm seeing this negative 14y and negative 7y, and I know that 7 can become 14. So I'm going to change my y's so that they become additive inverses of each other. Since my top one is a negative 14, I want to make my bottom one a positive 14. To do that, I'm going to multiply my entire equation by a negative 2, okay, by multiplying by -2 on my -7, that will leave me with a positive 14y. And that's what I want. So let's start by rewriting my top equation because nothing changed there. And then I'm going to rewrite the bottom equation. After multiplying everything by -2, I get minus 2x plus 14y equals a positive because we did a multiply by negatives. And this one was a 28, positive 28. Okay, so seeing how that's going to cancel as well, right? So now that I have my additive inverse to cancel out my y's, we can stack and add. 3x minus 2x gives me a single x left over. There are no y's left because we have that additive inverse canceling each other. And what's interesting is that this -28 and positive 28 cancel out each other as well as additive inverses. And just like how we saw prior, x equals 0 as half of my solution here. And we just go ahead and substitute. Okay, I'm going to use again the bottom equation, x minus 7y equals -14, because then I don't have to do any multiplication on my x. I'm going to substitute x for 0 because that's what I solved for. 7y equals -14. So I need to now, since 0 is nothing, it really isn't there. It's like a -7y equals -14. I can divide by my -7s and get y equals positive 2. So again, just like we saw before, my final solution is a 0, 2. Okay, so that is 2 ways that you could have solved number 1 by either canceling your x's or your y's. Again, you could use larger numbers, like if you decided to multiply both equations, as long as you're keeping everything equal and multiplying the entire equation, and then making sure that when you multiply your equations, you are giving yourselves that additive inverse, making opposite signs to cancel. Okay? Good luck, and let me know if you need any help.